Welcome to another video, the same every time, IGCSE Maths, GCSE Maths. The idea is if we learn how to do the questions that are the same every time, you get the marks, you get yourself into the grades. So the same every time, highest common factors. Find the highest common factor, or HCF, of 72 and 90. I'm going to do this question non-calculator. On some exam boards, of course, there's a non-calculator paper, so it's all good practice. Now, this is related to the topic of factor trees and product of prime factors, because perhaps the best way to do this is to use factor trees and prime factorization. So I'm going to start with my factor tree with 72, and I have to think of two numbers that multiply to make 72. Well, I'm going to go for 2 and 36. Not the only options, of course. It doesn't matter how you start your factor tree, you're going to get the same prime numbers at the end anyway. So 2 is a prime number. If you're not sure how to do this, then have a look at the previous videos about prime factors and factor trees. 36, I think I'll go with two numbers that multiply to make 36. 3 times 12. 3 is a prime number, so I circle it. 12, more than one option. I think this time I'll go for 3 times 4. 3 multiplied by 4. 3 is a prime number, so I circle it. And two numbers that multiply to make 4. 2 and 2. So 2 prime numbers there, 2 and 2. Now, I must also do a factor tree for the second number, which was 90. So two numbers that multiply to make 90. I think the most obvious would be 9 times 10. None of those is a prime number, so I'll continue. 9 would be 3 times 3, and 10 I can write as 2 times 5. So prime numbers here, circling them, would be 3 and 3. 2 is a prime number, 5 is a prime number. So I'm going to write my two numbers there, the 72 and the 90, as a product of prime numbers, prime factors. So 72 is 2 times 2 times 2, which is 2 to the power 3. I'll go straight to the index notation. If you're not sure about that, watch the videos about product of prime factors and factor trees, multiplied by 3 to the power 2. So my 72 is 2 times 2 times 2 times 3 times 3. 90, as a product of prime numbers, is 2 times 3 times 3 times 5. So 2 times 3 squared times by 5. Now we can read off, or we can work out, the highest common factor from my prime factorizations here. All I have to do is look for the numbers that occur in both of them. So 2 here and 2 here. Never mind the powers for now. There's a 2 in both of my factorizations. 3 here, 3 here. So there's a 3 in both of my factorizations. The 5 only happens in the 90, so I don't include the 5 for my highest common factor. Then what I have to do is put the powers here. So I need the smallest power of each number. So in the 72, I've got 2 to the power 3. In the 90, I've just got 2, which is 2 to the power 1. So the smallest power, 3 and 1, is 2 to the power 1. For the 3, in the 72, I've got 3 to the power 2, and in the 90, I've got 3 to the power 2, so the smallest power is power 2. I need to multiply those together, so that's going to be 2 multiplied by 3 to the power 2, which is 3 times 3, 9. 2 times 9 gives me my final answer of 18. So the highest common factor, the biggest number that will divide into 72 and 90 is 18. This isn't the only way to do this, of course. If I wanted to, I could just write down all the factors of 72 and all the factors of 90. Doing that non-calculator might be a bit awkward, and also it's very easy to miss them off. Remember our topic here, the same every time. We're looking for one method that's going to work every time. I recommend this method for finding the highest common factor. Use your factor trees to find the prime factors of 72 and 90. Then look for the numbers, the prime numbers that occur in both of my factorizations. Then the smallest powers multiply together. In this case, 2 times 9, 18. Well, a little bit complicated, I suppose. There's a lot going on with this. I'll put up some more videos for this, and then you can practice and compare your answers with mine. If you did find that video useful, then please do press the subscribe button because that's useful to the channel. I will see you on the next one.